Hey, how's it going, guys? Your friend Jim here with another video. In this video, we're going to talk about the four-wheel drive system on the 2004 Mitsubishi Montero. But before we get to that, I want to thank all of the new subscribers to my channel. Thanks to all the guys that like and comment on my videos. Greatly appreciate that. I really enjoy the interaction with you guys. Thank you so much for that. So in this video, we're just going to go over quickly the four-wheel drive system on the Montero. This is almost like an introduction video to the four-wheel drive system. I'll talk a little bit about it, go over the functions of it and stuff like that. And on my next video, we're going to do a deep dive into the four-wheel drive system in terms of diagnostic and operation and stuff like that. We're going to go and talk about each component, mainly how to diagnose it. Basically getting into the four-wheel drive ECU, checking voltage inputs, voltage outputs, stuff like that. So we're gonna get deep into it on the next video. This video, let's just talk about some of the basics. I mean, four-wheel drive system on the Montero is a pretty capable vehicle. It has a lot of electronics, so it works like a regular mechanical four-wheel drive system, but it works in conjunction with the traction control system to make it function as if the differentials had lockers, sort of as if we had limited slip differentials. But the key to that is that your traction control system has to be operating. If it's disabled due to a check engine light or due to some other condition and your traction control system is disabled, then the four-wheel drive system is not going to function as well as it could. So, but we'll talk more about that later on. Right now, let's just go over some of the basic functions. There's the Montero, looking pretty. As I mentioned recently, I got rear-ended, and the rear bumper basically had a little crack on it. I'll show you guys. But basically, while I had it at the body shop, I had them repaint the front bumper because some of this was peeling off, and then also this side panel, I had it repainted. So we do have a new rear bumper with this new stepping area here. I did get the Rally Art sticker from Luso Overland. Thank you guys for that. It looks really cool. I love it. I do have the ramps set up because I was going to try to demonstrate the four-wheel drive operation. But I'm not going to do that in this video. We're going to do that on the next video. Right now, we're just going to talk about some of the basic functions. And here we are inside the Montero. And again, we're just going to talk about the basic functions, four-wheel drive system functions, indicator lights here on the dash, and stuff like that. And then later on, we'll also go under the vehicle and talk about some of that stuff there. Okay, so basically, this is where we control our four-wheel drive system. We have two-wheel drive, we have four high locked, and four low locked. Right now I have it in four low, just because I was trying to do some experimenting on those ramps that I showed you. So let me start the engine here. And as you can see, we have all these lights are on. All four green wheels. We have the center differential light. We have the four low light on. So everything is on. The vehicle is mechanically in four low right now. You can tell that it's in four low because it has a lot of torque. It's providing maximum power out to the wheels due to low gear engagement. It's almost like a little tractor, sort of. So now, as mentioned, we have it in four low log. So I'm going to get it out of four low log, but to go in and out of four low, the transmission has to be in neutral. Transmission's in neutral, and then you can see the lights. You can see the four low light turned off. Okay, so we're out of four low. Now we can go back to park. Now we're just in regular four high locked, and you can see because the center differential is locked there. What we mean by lock is you're locking the center differential. The transfer case, inside the transfer case there is a differential, and when you put it in four high locked or four low locked, basically you're locking that center differential, meaning that the front shaft the input shaft to the differential and the output shaft out of the differential are basically mechanically locked together. So when you're in lock mode, 4-high locked or 4-low locked, you're going to have that binding effect, that binding sensation when you make a turn, because the both input shaft to the transfer case and output shaft, they want to turn at different speeds, but since it's locked, it gives you that binding sensation. And that's when you're in lock, differential lock mode. When you are, so let me get it out of lock mode. So here I'm gonna move this lever to 4-high, just regular 4-high, and that center differential light is gonna turn off. There, it turned off. You can feel a little bump on the, you can feel a little bump when it engages and disengages, and you can see the light come off. So the way this system works, basically I'm telling it this switch is not a mechanical connection to the transfer case. This is basically a switch telling a computer to do what you want it to do. Then the computer will do that function on the transfer case, and it has detection switches. The detection switches tell the computer, okay, I'm already there, or wait a minute, no I'm not. So until the transfer case disengages or engages, depending on what you want to do, the computer has to get confirmation from the detection switches in order for the light to come on or for the light to go out. If you move it, if you move the selector switch, the computer tries to move the transfer case and it does move, but it does not get the confirmation from the detection switches. That's when you get the blinking light over here, the center differential blinking light. When that happens, the computer disables everything, it starts blinking the light, and it stops trying to move anything. It just ignores everything until you fix the issue. And that's what I was telling you guys earlier. On my next video, we're gonna get deep into that function. So now we're in just regular 4-high. See that? It's in 4-high. Transmission's in 4-high. Transfer case is in, I'm sorry, transfer case is in 4-high. And what's the difference between 4-high and 4-high locked? Well, as I was telling you guys earlier, 4-high locked is the center differential in the transfer case is locked. It's a mechanical connection between the two shafts. 4-high, not 4-high locked, just 4-high. It's still in 4-high, but the center differential, or the input shaft and the output shaft of the transfer case, are connected through a viscous coupler. It's sort of they're connected, but they're not 100% mechanically connected. It's connected through a viscous coupler. It's similar to the torque converter in your transmission. Part of your torque converter is connected to the flywheel, the other side is connected to the input shaft of the transmission. So there's a connection there, but it's a hydraulic connection, and that's how it transmits the power from one shaft to the other shaft. So similar to that, inside the transfer case there is a viscous coupler that transfers the power from the input shaft to the output shaft with a hydraulic connection type of thing. And that's the reason why when you have it in 4-high and you're making a U-turn or a no-turn, whatever you're doing, you don't hear that, you don't have that binding, because it doesn't matter if one shaft is turning faster than the other one. It's not a mechanical connection, it's a hydraulic connection. So you're not going to feel that mechanical binding between the two shafts. So that's 4-high. When you drive it in 4-high on dry pavement, you put the, or even if it's not dry pavement, no matter what, if you're driving in 4-high, you are putting the fluid under maximum stress. So if you constantly drive your vehicle in 4-high, then you need to make sure that your fluid is okay. You need to change it more often than somebody that doesn't drive it constantly in 4-high. Normally, I usually drive my vehicle in 2-high. So in this position here. So when I put it in 2-high, you'll see that the front wheels are gonna turn off. I can hear the little motor. You can sort of feel that the vehicle is doing that, because you can hear a little bump when it engages and when it disengages. So that's 2-high right there, and that's the way I normally drive my vehicle. So those are the functions here inside the vehicle for your 4-wheel drive system. Now, if you notice, I do have service engine soon light right there. Okay, that's a P0431 that I've been dealing with for the last year. I'm gonna replace the catalytic converter. I really have no choice. My smog check is coming up in June, so I have 6 months to do that. But here's the important part where that light comes into play in terms of your four-wheel drive system. If I put it in 4 high, there, it engaged 4 high. Now I'm going to go to 4 high locked. Okay, now I'm going to go to 4 low. I'll put it in neutral, and I'm going to go to 4 low locked. You saw that? It went into 4 low. But what also happened, traction control off light. So because I have a service engine soon light, computer doesn't know, you have to fix that. Computer doesn't know what's going on. I want 4 low, but the computer is turning off traction control. If my traction control system is off, 4 low will still engage, but it's not going to have that optimum performance in 4 low. And we'll talk a little bit more about that in just a second. So as I was mentioning, that's just a regular open differential. It's not, the axles are not connected to the wheels. It's just a differential. When the front shaft is turning, it turns the differential, but you also have to engage the wheels. Just like on my Chevy truck, but on my Chevy truck we have manual controllers. I'll show you here real quick. Get up. So on my Chevy truck, when I put it in 4-wheel drive, I have to come out of the vehicle and turn these guys so I can engage this shaft to the differential, and there's another one on the other wheel. So that's how you do it on these older vehicles. It's a manual control. But the legendary Mitsubishi Montero, it's not manual, it's automatic based on that actuator down there. So that's how, when you put it in 4 high, the computer activates the solenoids, and it causes that actuator to engage the wheels. Even when the wheels are engaged though, it's still an open-ended differential. It's still not like a locked differential or even a limited slip differential. All right, so let's continue on here. We're gonna talk about some basic operation here on the Mitsubishi 4-wheel drive system. Basically, what makes the magic happen on the Mitsubishi 4-wheel drive system is these two systems working together. What they call the 4-wheel drive system on the Mitsubishi Montero, they call it the Active Track 4-wheel drive 2 system. And this system works in conjunction with the M-ASTC. The M-ASTC system is the Mitsubishi Active Track, Active Skid, and Traction Control System. So these two systems work together to make the 4-wheel drive system function properly. Now, we're just going to cover, just for basic knowledge purposes, we're just going to cover a basic powertrain, which we have here. So basically, if this is too basic for you, then go ahead and move forward. But for those of you who are starting to learn how these systems operate, and sometimes when we talk about certain things it's a little bit confusing, let me just bring it back to a super basic level so that you can understand what we're talking about here. So this is what we call the powertrain. So the powertrain is starts at the engine and it ends at the wheels. Basically, the power is generated in the engine, it goes into the transmission, then it goes to the transfer case, and then we have a rear drive shaft and a rear differential. When you engage the transfer case in 4-wheel drive, whether it's 4 high locked, or 4 low locked, the transfer case sends power to the front shaft as well. So now power comes out of the engine into the transmission, out of the transmission into the transfer case, out to both shafts, this guy and this guy. Then we go into the differentials. The rear differential, which is mechanically connected to the wheels, and it functions just like a regular open-ended differential, meaning that it's not a limited slip differential, and it doesn't have lockers. You can add lockers to these. They sell them at Luso Overland, which might help or actually will help. And also, when the transfer case sends power to the front shaft, it goes to the front differential. The front differential is also an open-ended differential. However, this differential is not constantly connected to the wheels. When we engage four-wheel drive, we also have to lock the front differential. Similar to how I showed you, like on my Chevy truck, you have to lock it manually to engage the shafts, the shafts to the wheels, to the hubs, into the differential. The same thing with this one. This one doesn't have those manual hub lockers, but it does have it automatically. It does have an actuator here that works with the vacuum. There's a couple of vacuum solenoids underneath the air cleaner, and via those solenoids, the computer controls the vacuum to engage this front differential and the vacuum to disengage the front differential. And I'll show you that on the vehicle here in a minute. When you go to two-wheel drive and no more power is being sent to the front shaft, then there's no reason why this differential should be connected to these two wheels. If you have that connected, then it's going to waste more gas. It's just not something that it's not designed that way. You just disengage it when you want four-wheel drive, then you engage the front differential. However, the rear differential, since when we're in two-wheel drive or too high, it's functioning with the rear wheels. The rear wheels don't need to be engaged and disengaged to the rear differential. It's always engaged. It's always a mechanical connection between these shafts and the rear differential. So there's no need to disengage. However, even though it's fully engaged at all times, it's still an open-ended differential. Again, meaning it's not limited slip, and it is not it's not mechanically engaged. So basically, when you are driving the vehicle on an open-ended differential, one wheel has traction, the other wheel does not have traction. The power is going to automatically go to the one that does not have traction, and then this one's gonna spin, this one's gonna try to go over a rock. And that's the way an open differential works. That's why people get lockers, because when you are going through an obstacle, this one's trying to go over a rock, this one's spinning, you lock the differential, so now you have 50% power going this way, 50% going that way. So now the differential is completely locked, and it's going to go over that rock. There's also limited slip differentials, meaning that when this wheel is going over a rock, this one is slipping. There's a mechanism inside the differential that limits how much that can slip, and when that limit kicks in, power goes to the wheel that's trying to go over the rock, and that's a limited slip differential. The beauty of the Mitsubishi four-wheel drive system is that it doesn't have lockers, it doesn't have limited slip, but it has the traction control system, that when the computer detects that this wheel is going over a rock, this wheel spinning, the computer will hit the brakes, will send brake pressure to this caliper to stop this wheel from turning, allowing the differential to send rotational power to this wheel that's trying to go over a rock. That is the way the four-wheel drive system works in conjunction with the active skid and traction control system to make it act as if this had limited slip and or lockers. However, the computer has to see this wheel turning before it kicks in and sends power to this wheel. So if you have mechanical lockers, air lockers, or electrical lockers, you don't have to worry about that delay. That happens automatically. You don't have to rely on the computer seeing this wheel turning before it kicks in, before it hits the brakes on it, allowing power to go to the wheel trying to go over the rock. Exactly the same way, the front section functions exactly the same way. Every wheel, the computer has brake control over every wheel, depending on the driving condition, the driving situation that you are in. However, as I explained earlier, if you have a check engine light on or any other condition that has disabled the traction control system, then that function where the computer pushes on, where the computer brakes the spinning wheel to allow the other wheel to go over the rock, that particular function does not work anymore. Why? Because the traction control system is disabled. So make sure if you're going out to the trail, just be aware that if you have a traction control system that gets disabled when you go to 4 low, then that function is not going to work. You're basically going to be trying to go over obstacles with 2 open-ended differentials, and that makes it a little bit difficult, and you're not getting the full advantage that the properly functioning Mitsubishi Montero 4-wheel drive system offers. So just FYI there. Sorry, it was a big rant, but let me know if you have any questions on that. I'll be happy to answer. Alright guys, so now that we went over some of the basic functions of the 4-wheel drive system, and I showed you the diagram and some of the components, some of the operation, just basic theory behind it. Let's go under the vehicle and I'll show you the actual components so you can be familiar with them. Alright, let's get going. Alright guys, so now I got my flashlight here, and I do have the creeper there. Let's crawl down there. We'll look at some of the components, talk about all the components that we just talked about on the diagram there. So let's see here. Let's see if I can get in here. All right. So here's a Montero. I have it on the ramps. Okay. All right. So here we are. So I have the Montero on the ramps. As you can see, the front wheels are on the ramps. The back wheel is on the jack, and it's not lifted all the way. I just have it lifted enough for me to crawl in here. I don't have the jack stands or anything because the wheels are still on. So if the jack fails, it's not going anywhere. So I'm gonna turn the camera around so you can see what I see. And here we have the skid plate. Right here we have the front differential. Again, this is an open-ended differential. It's not constantly connected to the wheels, but it does have an actuator. This guy here is a vacuum controlled actuator that engages the differential to the hubs, and it does have a diaphragm here. It's a vacuum controlled actuator. There is a little vacuum tank right here. This little tank is a vacuum tank. The computer uses a couple of solenoids underneath the air cleaner to control the vacuum on these 2 hoses, one to disengage, one to engage, and then this actuator engages or disengages the hubs from the differential. It does have a little detection switch right here that once the differential engages, this sends confirmation to the computer that it's engaged. And again, as I was telling you guys during on the diagram, we have the engine right in here. Power goes out from the engine into the transmission, and then we have the transfer case right here. So this would be the transfer case, and basically this component here is in charge of receiving the power from the transmission and then sending it out to the rear drive shaft, to the rear differential. But when you engage 4-wheel drive, it also sends power to the front shaft, to the front differential right there. Here's the front shaft right there, and the front differential over there. So this transfer case, there's a bunch of detection switches up here on top of this transfer case, because keep in mind, you are not actually mechanically controlling the transfer case with the lever. The lever that when you select 4-wheel drive, 4 high locked or 4 low locked, it's just a switch. You're just moving a switch, and that switch is telling the computer what you want it to do, and then the computer will do that job, and these detection switches up here will confirm that it actually entered into that position or not. And there's about five of them here. I did replace them once. I replaced all 5 once. It's really not a big job, but it's one of those jobs where you have to drop this cross member. You have to drop it so that the transfer case can drop a little bit, enough for you to get your hand in there. And it's one of those jobs where you can't see what you're doing, you can only feel what you're doing. It's not impossible, but it's not the easiest job to do either. And then here we have the rear drive shaft, which is the carbon fiber, super awesome drive shaft, but it is a little bit delicate. So it basically, having skid plate down here is if you'll go off-roading a lot, it's probably not a bad idea. And then here we have the rear differential. Rear differential is just like any other differential. It's connected constantly to the rear wheels, but again, it is an open-ended differential. It's not a limited slip differential, and it does not have built-in lockers or anything, meaning if this wheel is trying to go over a rock and that wheel is just going to be spinning. And that's what an open-ended differential is. That's how my Chevy truck, Jeep, that's how they are, unless you have limited slip differential or if you have lockers. But what makes the Mitsubishi Montero so special is that when that particular situation happens, this wheel's trying to go over a rock, that wheel is spinning, the computer using the traction control system will stop this wheel from turning, allowing more power to go to this other wheel, allowing the rotational force to go to this wheel so it can go over that rock, as I was mentioning earlier. So that's the magic. That's what makes this the Montero 4-wheel drive system so special, just because it has that function. But remember, if you have a check engine light on or any other issue that disables the traction control system, then it's not going to work. You're gonna have just a basic 4-wheel drive system, just basically like I do on my Chevy truck. So that's why a lot of people just get the lockers and they don't have to worry about the traction control, because they just mechanically lock it and you don't have to worry about the computer functioning, doing that function. All right, guys, I think we're done. Let me get up here. Okay, let's see. So thank you guys for watching. I think we pretty much covered everything for this video, for this introduction video. Please let me know if you have any questions or any comments or anything like that. If I misspoke or said something that was not valid or whatever, just let me know. I probably did. It's not a big deal, but you kind of get the picture. And again, on my next video, I'm gonna do a deep dive on that system. We're gonna go to the 4-wheel drive ECU. We're gonna check voltage on certain components. I'm gonna put a bug in there so it can have a flashing center differential light, and we're gonna go through the diagnostic process of that. And it's pretty much standard, no matter what's going on with it. It's pretty much standard. It's pretty much a standard diagnostic procedure on this 4-wheel drive system, and it's the same, basically the same for Toyota models and Mitsubishi models. So it's basically the same process that we take, same diagnostic approach that we take on these systems. And since we don't have scan tool data for the 4-wheel drive system, we have to use a voltmeter on each terminal so we can see the inputs and the outputs. And it's a little more involved, but it gets the job done. I'm sorry. Anyway, guys, today is December 31st, 2023, the last day of the year. I want to wish all of you guys a happy new year, and let's strive to make better versions of ourselves in 2024. I know that's going to be one of my goals, and I hope it is yours as well. Thank you guys for watching. If you stayed to the end, greatly appreciate that. Please give me a like, share this video with your family members, and also comment, send me a comment. So thank you so much. I will see you on the next one. Thank you. Bye.